Hi guys, today we are learning about how to solve radical equations. That means any kind of equation that has a radical sign in it. So here we go. The first thing we want to do every single time that we try to solve a radical equation is we want to get the thing with the radical sign by itself. Okay, so for instance, I look here at this very first problem. I have the square root of x, but then I'm subtracting 4 from it. So my first step is actually to go through and add 4 to both sides. Okay, and after I add 4 to both sides, then I'll see that x, the square root of x by itself, is equal to 27. And this is going to be a pretty large number, I just realized whenever we get the answer here, because what I need to do next is get rid of the square root sign, right? And so I get rid of a square root sign by doing the opposite of a square root, which is squaring both sides, okay? And so when I set this up, I chose a pretty dumb example here because that's going to be a large number. But the square root of a square, well, these two things end up going away, so I ended up just having an x. And the answer is whatever 27 squared is, which I'm going to need a calculator for that one, the answer is 729, okay? So x had to be 729. I can easily check my solution, and this is a habit that we want to get into because we're going to find the second day that we work on these radical equations, we're going to find some problems that have numbers like 729. We're going to go put them back into the original equation, and it's not going to work. It's something called an extraneous solution. That's a later video, okay? But I can easily check it just by throwing it into always to the original equation, and I just say, hey, if I took the square root of 729 and I subtracted 4, would it equal 23? And so I go through on my calculator and I just go, okay, well, 729 is this, and I'm going to take the square root of that value, and that gives me 27, and I'm going to subtract 4. And that does indeed give me 23, right? So the square root of 729 is 27. And if I took 27 minus 4, that does indeed equal 23. So we get like a smiley face or something over here, or a little check mark, something that signifies, hey, we've checked that off. It does indeed work with the original equation. So let's look at another example here. We have 3 times the square root of x minus 5 equals 9, okay? This time, I have the square root sign here, but I don't have just a square root of x minus 5. I have 3 of those, right? 3 times it. So we need to get rid of the 3 first by dividing by 3. And so now I have a single square root of x minus 5, and that thing is equal to 3. Once again, now, I've got the square root by itself, so I'm ready to go get rid of it, and the opposite of a square root is a square. So I'm going to square both sides, and that leaves me just with the x minus 5 on the left, the thing inside the square root sign, because the square root and the square went away. 3 squared is 9. Now I take x minus 5. I need to add 5 to both sides to find out what x is. X is 9 plus 5, which is 14. Let's go through and let's check it out. Does 3 times the square root of 14 minus 5, always back to the original equation, does it equal 9? That's the question. Well, that would be 3 times the square root of 14 minus 5 is 9. Does that equal 9? Well, the square root of 9 is just 3, right? So 3 times 3. Does 3 times 3 equal 9? Yes, it does. 9 is equal to 9, so we get a smiley face or whatever kind of symbol you want to do to signify that, hey, listen, I've walked that through. I put it back into the original equation. That number does indeed work, okay? So the answer on this one is 14. One last video here for this. The only change here is that they gave you a fractional exponent, and remember, 1/2 power is the same thing as a square root. So really, this is the square root of x plus 1 is what it is. Okay, but the same idea holds, is that we want to get the thing with the fractional exponent by itself first. So step 1 is to get rid of this 4. 3 times the square root of x plus 1, or x plus 1 to the 1/2, would be equal to 21. I got that by adding 4 to both sides. I guess I should have written that out, right? And now I have 3 of these things, so I need to divide both sides by 3, so those go away, and I'm left with the x plus 1 to the 1/2 power is equal to 21 divided by 3 is 7, right? Really, remember, that's the same thing as a square root, okay? So now what I'm going to do is I'm going to raise both sides to the same power. What do I do to get rid of 1/2? I multiply by the reciprocal of 2 over 1. I square, right? I square both sides. So I'm just going to write it as squared on the right side. That's okay. But basically all I did is I squared a square root here, okay? Because whenever I raise a power to a power, I take 1/2 times 2 over 1, and we see that everything goes away. I'm just left with the first power, right? So in other words, we're squaring a square root because that makes it go away. On the right-hand side, I have 7 squared, which is 49. Be careful here. I think a lot of people probably tell me 50, but we need to subtract 1, And the answer is 48. X is 48. Let's go back and let's make sure that that works. Okay, so if I took 3 times 48 plus 1 and raised it to the 1/2 power and then subtracted 4, would that equal 17? That's the question. Well, that would be 3 times 49 to the 1/2 power and then subtracting 4. Does that equal 17? 49 to the 1/2 power really means the square root of 49, so we're really talking 7. Is 3 times 7 minus 4, is that equal to 17? Run out of room, right? 3 times 7 is 21, and 21 minus 4 is 17, so 17 does indeed equal 17. Happy face. Hey, everybody's happy because the solution worked. So hopefully that makes sense to you, and that's what we're going to do. Okay, hope you got those last few steps. Hopefully that makes sense. That's how we deal with square root signs. In the next video, I'm going to talk about how to deal with cube roots, which you see down here below. Same process, just a slightly different twist, but I think it's going to make a lot of sense to you.